All right, mathematicians, I'm going to be using these slides and modeling how you can use thinking about a benchmark of one whole to compare fractions that are close to a whole. So a prerequisite skill is that you have to know all the ways that you can make one whole with fractions. So we all know that this top bar is one whole bar, but also if you did the second one that's split into two equal parts, those parts are called halves, right? How many halves make one whole? Well, I can see that there's two halves that make one whole. So these fraction bars and this ratio table are two models to show these equivalent fractions. 1 over 1, that's the same as one whole. 2 halves, that's the same as one whole. If I wanted to look at my next row down, I have 3 equal parts or thirds, and 3/3 are the same as one whole. You guys might already be noticing a pattern here. If I go to my next bar down, it's split into 4 equal parts or fourths, and 4/4 are the same as one whole. So all of these fractions that I'm typing in here are equivalent to one whole. Fix that for you guys so it's nice when you guys do it. So once I understand that one whole can be 1 over 1 or 2 halves or 3/3 or 4/4, and you keep it going, then you're ready to use this strategy of using a benchmark of one whole. So I'm just going to pop down to a different slide. This one does have a number line model just to give some variety. When I look at these numbers or these fractions, I see 4/5 and I see 7/8. Now I know that 5/5 makes one whole, and I know that 8/8 make one whole. So this would be a perfect problem to use this unit fraction away from the whole thinking. So let's try dragging my words over to match. This is 4/5, and this one is 7/8. So I'm going to drag my words down, and then I'm going to model these fractions on my number line. So 4/5, I'm looking for the number line that is split into 5 equal parts. I think I see it. I'm going to bring this right down. Let's see, 1, 2, 3, 4, 5. This number line, this whole number line has been split into 5 equal parts or 5 chunks. This is 5/5. This is one whole, right? 4/5 would just be 1/5 less than a whole. So I'm going to back it up 1/5. So that blue represents 1/5. Sometimes you might have an X or a point that's on this area of the number line that can also represent 4/5 of the number line. Now I'm going to model 7/8 with my red. I'm looking for the line that is split into 8 equal parts or eighths. I believe it's this. So I know that 8/8 is the same as one whole, but 7/8, I just need to take off 1/8. Now this is where your thinking and your understanding about unit fractions really comes into play. If you understand that fifths are larger than eighths, because the less times I cut my whole, the larger the unit fractions are, then you can use that understanding to help you with this. 4/5 is 1/5 away from one whole. See? 7/8 is 1/8 away from one whole. Since 1/8 is a smaller piece than 1/5, 7/8 is actually closer to the whole, which means that it's greater than 4/5. So I'll put a G over 7/8 and an L over 4/5. And when I read this, I'm going to read it from left to right. 4/5 is less than 7/8. And finally, I can drag over my inequality sign that matches. Remember, the opening of your inequality sign will be facing that greater fraction. So this would be 4/5 is less than 7/8. All right, there's some more for you guys to practice. Remember, when you see your fraction on a number line, it may not, this kind of looks like the area model. You might have an X or a dot here to mark 4/5 where that is on the number line. But whether it's an X or whether you're using these bars, whether you're using an area model or a number line model, the reasoning is still the same. Happy practicing.